Right, thank you all for coming along today. My name is Michael Ewens. I'm a Director of Engineering at Skyscanner, and this is my colleague JM LaPlante, who's also here at Skyscanner. So we'd like to share our story from the last, 2, 3, 4 years of enabling data and AI governance at Skyscanner. But for those that don't know who Skyscanner are, I'm going to kick off with a very short kind of intro about who we are. Right, so Skyscanner are a global leader in travel. We serve more than 110 million users every month to plan and book their trips, travel trips with confidence and ease. We operate in over 30 languages, and we connect travelers to flights, hotels, and car rental options from over 1,200 travel partners across 180 different countries. So we have been using data extensively for the last 20 years, and we've been using it primarily to enhance the traveler experience and support decision-making within the business. Over the last few years, we've launched machine learning models to rank and recommend travel options, and we recently launched an in-app AI search capability to inspire travelers to help them discover new and interesting locations. So Skyscanner operates at scale. We process over 30 billion messages per day, or events per day from our apps. And we have about 15 petabytes of data at rest within our ecosystem. We've got hundreds of engineers at Skyscanner and also data specialists, and they're all collaborating within our data ecosystem. So want to take you back a few years so you understand like the data challenges we had at the start of our journey. So if we roll back to about 2020, we had frequent data delays, we had data completeness issues, and these were arising from kind of our complex systems, complex data pipelines. And we basically experienced incidents pretty much every day when we first kind of joined in our data tribe. And so we needed reliability. This is a handcrafted lineage diagram from about early 2021, and we had poorly understood and complex dependencies. An awful lot of tacit knowledge was required to understand what was going on, if we needed to debug a system or troubleshoot a system. And ultimately, what we needed was data we could trust. And this chart is from 2020. We did like a current reality tree mapping exercise where we kind of looked at all the different systems that we had. And basically, if you think of a technology from the last like 5, 10 years for data enablement, we had them all. So data was difficult to join across our different systems. It was slow, it was cumbersome for the teams to use, and we were receiving inconsistent answers from the different systems. And so what we wanted was to enable the business to get high quality, high velocity decisions from our data. So to do that, one of the things that we did was we created a centralized data tribe and with 3 kind of core kind of mission statements, if you will. Reliability, trust in our data, and enabling smart decisions quickly using that data. So I'm now going to explain how we overcame those challenges over the last few years. See, is it updating? Oops. Right, I'm going to start with this comic from XKCD. I don't know if you're familiar with XKCD, but this sums up the challenges that we were experiencing. Basically, we were building more systems, we were building more pipelines, and all that we were ending up with was more complexity. And we recognized that we needed to simplify. So we mapped out a high-level journey for our data. This staircase, I'll come back to it a few times during today's talk. And the starting point for that was simplification. So a key decision that we made to help us simplify was to invest our data platform and data governance efforts around our existing medallion architecture. So we wanted all data to land in bronze. Previously, we had data landing in, it was ingested into different systems and different pathways. We wanted to transform our data using a single technology stack, Previously, we were transforming data in multiple different technology stacks, and that was like out of alignment with our hiring strategy that we had at the time. And we wanted to be able to consume our data from Medallion, where it would have been enriched, pre-joined to enable various use cases. So the second step in our journey was we engaged Databricks to, to conduct a data maturity assessment. We wanted to benchmark ourselves against other companies. We wanted to understand what good looked like, and so that we can learn from other people. Let's see if this updates. And so this is a copy, one of the slides from the maturity assessment that we did with Databricks. And from this, we learned where we really needed to and could improve. And we aligned on an action plan around data discoverability, enabling trust in our data, and also enabling the business, enabling data across the business. Is this updating? So I'm now going to share how we enabled trust in our data. So as mentioned earlier, Skyscanner is operating at scale. We've got thousands of data sets, we've got hundreds of engineers and data specialists, and we needed a way to share our progress towards healthy data. And we wanted to be able to communicate with our stakeholders with clarity about what we were trying to do and where we were on that journey. Excuse me a second. So when we started, we had 30,000 data sets within our Hive Metastore, but we'd learned from multiple incidents that we'd experienced that not all data is equal. So one of the first things we do is we identified what are our business critical use cases. And from that, we identified what are the business critical data sets that powered those use cases. And so there was approximately 350 different business critical data sets. The second step that we took was to introduce a framework for thinking about and communicating healthy data. And this would guide us on our journey towards data governance. So level one is all about ownership. All data needs an owner. And ownership at Skyscanner is based on teams, not individuals. And teams are responsible for the data that they produce. That was an engineering principle that we'd introduced in 2018. But we also wanted teams to be responsible for the data that they choose to consume. But in order to enable that, we had to enable trust. Level two of our healthy data framework is to understand questions like, where does my data come from? Who's using my data? If you're in data at all, you'll be familiar with the concept of lineage. And we also wanted to improve access control, and so that we would enable teams to collaborate in the right way. Level three of our healthy data framework allows us to understand, is my data complete? Is it arriving on time? If you think back to the incident chart that I showed you right at the start of the talk, we had lots of completeness issues, lots of timeliness issues. And these are typically table level checks, and they would help us understand and improve on our data quality. And finally, level four. As mentioned earlier, we'd learned that not all data is equal. And so we wanted the ability to dial up the checks that we're doing on our data. And essentially what this means is we wanted field level checks, but we're not going to do them on every table. We're going to do them on very specific tables or business critical tables, for example. And so this is our healthy data framework. To implement this, we made a couple of decisions. Number one was to adopt Unity Catalog, and that would help us on the ownership front, and it would help us with discoverability, with lineage, with access control. And then the second decision that we made was to adopt Monte Carlo. And we're using Monte Carlo for data observability at both the field and table level. And my colleague JM is going to talk about the decisions that we made to implement that shortly. So back to the staircase. So having enabled Unity Catalog and Monte Carlo, we needed to scale adoption across the organization. We had multiple teams, multiple disciplines, multiple departments, but they're all collaborating in the same data ecosystem. So we actually used the Healthy Data Framework to track our progress. We created a scoring mechanism based on the Healthy Data Framework. And the chart shows that we made rapid progress early on, then we slowed down, and then we started accelerating again. And I want to share what happened on that journey. So we had some initial successes when we were enabling Unity Catalog. So we could start to see the benefits, things like data domains that we introduced, like silver, and then various domains for business objects, and then the tables below that. And that would help us with data discoverability. And then we had table and field descriptions were getting added into Unity Catalog to help us understand the data. We had automated lineage, which was good. But the progress at this time was slow and it was frustrating. And we wanted to see how can we go faster. We could see the benefits, but we needed to go faster. So I'm actually going to take you back a year to the Data and AI Summit of 2023. I wasn't at the summit last year, but I watched a ton of the videos online, and we took inspiration from a couple of the speakers. There was a company called Yipit Data who shared a story about how they enabled Unity Catalog without their teams modifying their code. And that was a fantastic idea. I've seen other people today talking about a similar kind of concept, but we couldn't use the same approach that they used. We needed to find our own way of achieving that. And Databricks also announced system tables, and that was a breakthrough as well for us because it allowed us to see what was happening on reads and writes outside of Unity Catalog, so we could see what was happening in our Hive metastore. And we actually learned from that we actually only had 1,500 active tables, not the 30,000 that we first thought of. And together, these two concepts inspired us to kick off a program called Unity Catalog Acceleration, and JM is going to share more on how we tackled that later. So along the way, we'd started on our journey. Along the way, we learned things, and we learned about metadata. We needed to introduce metadata so that we could automate aspects of data governance. And you can see we also introduced tracking and how we're doing on the adoption of our data governance across, adoption of the metadata across different parts of the medallion architecture. And so we introduced metadata such as data classification. So this gives us a taxonomy for data access. So is the data public, internal, confidential, restricted? And these are tools that we're going to use in the future to automate aspects of data governance. Data categorization is kind of building on ideas from like data mesh, where you've got analytical data and you've got operational data, and we've got subcategories is how we think about the data. Table and field descriptions are obviously very important for discoverability, but they're also with features like Project Genie. You can see how they're actually going to enable data democratization as well. And so the last thing I'm going to share at this point in time is we've actually further evolved our approach to data governance. We still have the pyramid that's quite a kind of powerful mechanism that we use, but we've adapted. We wanted more flexibility so we could introduce new areas where we wanted to improve our maturity and our approach to data governance. So for example, I think somewhere on that list is metadata. I think it's the third one down. And additionally, we wanted to be able to go out with really clear instructions to other teams across the business. The vast majority of people at Skyscanner, engineers, are not data specialists. They're working on different aspects of our apps. So we need to be really precise about what we need them to do and how to achieve that and why the ask is a priority. So at this point, I'm going to hand across to JM. And JM is going to give us a deeper dive into the implementation decisions behind the two parts of the story. Thank you.
Thank you, Michael, and hi, everyone. So I guess let's travel back in time a couple of years ago when we first started planning the enablement of Unity Catalog at Skyscanner. So it was clear from the start that Unity isn't just like another feature that you enable in Databricks, but it's more like a shift in how we can manage our data and also improve our governance. So we saw the introduction of Unity Catalog as an opportunity to re-platform, but also to improve some parts of our data architecture to build a more solid foundation to support our vision for more trust and reliability. The first thing I'll mention is that before we got started, the first step we took was to revisit and also to confirm eventually the decision that we previously made around how we organize our workspace topology in Databricks, because we've been using the tool for quite a few years already. That was important because it would influence later design decisions that I'll cover later. So next we focused our attention on making some more key decisions around how we want to organize our catalog and our schema structure within those catalogs. Because we wanted to align this to our medallion architecture, but also to the data domains that we had defined to organize our data products. Once we were happy with that, we decided how these catalogs should be used and should be made visible across our different workspaces. We wanted to balance convenience for our data consumers, but we also wanted to enforce the right access patterns where we needed them. We also reflected on our access control model to ensure we have tight enough controls over who can read, who can write data in Unity Catalog. There's a few other technical considerations that we looked into. So first, we wanted to ask ourselves how to organize the physical storage layer to allow for better reliability, flexibility, security. Also, we wanted to look at how to manage Unity Catalog alongside our Hive Metastore without impacting our users. And also quite important to us, we looked at what sort of self-serve capability we would be needing to reduce pressure on our data platform team, as well as how to implement those from a technical point of view. I guess with those in mind, let's take a look at some of the details of our architecture. So starting from the highest level, we currently have 2 Databricks workspaces, one for our development, testing, experimentation type workloads, and one for production workloads that we use for creating production data. So both of these workspaces are enabled to use Unity Catalog, and that's all configured in a single region as a single metastore. So it's a fairly simple setup. Going one level deeper in the object hierarchy, we've created separate catalogs per medallion layer in each of the workspaces to basically enable our medallion architecture. So for example, in production, we have a bronze catalog, a silver catalog, a gold catalog, and those are prefixed with the name of the workspace, so we're able to replicate the same setup in development as well. In terms of physical storage, we provision one platform centrally managed S3 bucket per catalog for storing things like managed tables and other Unity artifacts. And these are all defined as external locations in Unity. So essentially, data producers don't really need to worry about where their data gets stored, where it gets physically stored when they write to manage tables. That's all taken care of out of the box, and that was kind of a big improvement for us. One of the benefits of having platform managed storage is that it's enabled us to maintain and to roll out improvements to how we store our data. So one example of that is that we recently managed to roll out intelligent tiering across all our storage for Unity, and that's helped us make significant AWS storage cost savings, and that's not really something that we could have done easily or done at all with our previous data architecture. Looking at the catalog visibility, so we've set up our development workspace such that it's possible to query data from all our catalogs, whether it's in development or in production, of course, assuming that you've been granted permission to do so. Since most of our users run ad hoc queries in the development workspace, we felt that that was a convenient choice to make to maximize data discoverability. However, any of the workloads that we run in development can only write data to development catalogs, only no access to production, and that's pretty important. We'll see that in the next slide. So looking at our production workspace, we've set things up slightly differently, such that production workloads can only read data from production and write data to production catalogs. And that is not something that we are willing to negotiate on. Because the rule is in place to ensure that we can only use production data to power production use cases. That's helping us focus our effort on producing high quality production data, and that's a great foundation for building reliability and building trust. In terms of access control, one of the, I guess, the key decisions that we've made is to differentiate between the concept of technical ownership of the data and business ownership. So technical ownership, what does that actually mean? But I guess by that we refer to who is the owner of a schema, who is the owner of a table in Unity. And with that, you get provided full access to the data, full read and write access. So we decided that for us, it would be best if this role is not something that is provided to specific teams or people, and instead we limit this role to Databricks service principals only, so that basically only like Spark jobs can write data. Business ownership, on the other hand, is something that's foundational to our data governance framework, and that's a role that actually must be assumed by teams that are accountable for the data throughout its life cycle. It's something that we currently define using metadata by tagging schemas, by tagging tables. And in terms of access to the data, so the team that is the business owner of the data, they're the only people that get given read access by default. If anybody else wants to have access to read the data, then they must request it explicitly. So we're essentially applying the principle of least access to our data, and we're doing this for a couple of reasons. So the first reason is that we want business owners to be intentional about which data sets they expose to the wider organization. So we want them to be thinking about data products and how they will support those, rather than people having access to intermediate tables and all sorts of other data sets that are not well supported. The second reason is that this allows us to reduce the risk of restricted or confidential data being exposed to people that shouldn't have access to it. So here's an example of what that might look like in production. So here we have, in our medallion architecture, we have a marketing domain, which is essentially a schema in Unity catalog. And the technical ownership of this domain is assigned to a marketing service principal, and that's the only identity that can currently write the data to this domain. The marketing team, on the other hand, is the business owner of the data, and that team gets read access by default. Should they require access to other domains like bookings or flights domains, or service principals or business owners of those other domains requiring access to marketing domain data, then they need to request it explicitly. So we've not fully tested the limits of this model yet, but so far it's been working pretty good for us. There's other things that we might be looking at in the future, such as attribute-based access control, so that we can leverage some of the metadata that we capture on tables to grant read access dynamically, for example. So with all of this in place, we turned our attention to self-serve capabilities. The primary use case that we want to serve with self-serve capabilities is give the ability to business owners to create data domains and service principals that go with those. We also want to offer them the capability to manage who can read tables in the domains that they own. And to implement self-serve, we've basically leveraged the Databricks Terraform provider to create some reusable templates and automate deployments with those. So here's an example of what that might look like. So in this case, if we have a team that wants to create a new domain, then they can use this template. In this case, they have to provide the name of the domain they want to create, who tag themselves as the business owners of the domain, which catalog the domain will live in, and also they can specify which Databricks identities can read the data. So I guess overall, implementing self-serve capabilities has provided us with a few benefits. We are able to automate common tasks. We can also define our Unity catalog structure in source control configuration as code, and also we can reduce the risk of our data platform team becoming a bottleneck for our data organization. So circling back to the dataset health framework that Michael mentioned before, enabling Unity Catalog, that's brought us to a point where we have a lot of the capabilities that we need in order to build healthier data. So we can now define ownership on our data assets. We can tag data sets with all our essential metadata. We can track the lineage of our data and restrict access where we need it. But we still need to provide additional capabilities to achieve a higher level of data reliability. And for this, we decided to invest in Monte Carlo as our data observability platform and integrate it with Unity Catalog. So we won't dive into the details of how we implemented this because that's pretty simple, but it's worth pointing out that we selected Monte Carlo because it provides most of the capabilities that we need to instrument and to measure data reliability. We can get enhanced data lineage from what we get out of the box with Unity. We also get ML-based table-level monitors to look at things like freshness of the data, volume of data, and also schema changes. We also get a large number of out-of-the-box field-level quality metrics and also some basic data anomaly detection features. Also very important to us is alerting capabilities and also some data incident management tooling that helps us kind of troubleshooting issues when they're raised via one of our data quality monitors. So we're still in the process of onboarding teams to Monte Carlo and understanding how we can best leverage data observability as a capability, but we're already starting to see how that will help us on our journey to provide more reliable and trustworthy data. That is not something we could have achieved without first building a strong foundation with Unity Catalog. So now that all the pieces of the puzzle are in place, we're in a position where we can actually automate data health measurements and generate useful reports for our business. So we've been able to pull data from Unity, from Monte Carlo to calculate health scores per data sets using the criteria defined by data governance. This allows us to make the current state of our data visible to the data owners, to data governance, our leadership team, data stewards. And that's help us identify areas of improvements and also prioritize which actions we will actually want to move forward with. So as discussed by Michael earlier, being able to measure health improvements over time, that's made us realize that we're perhaps not going as fast as we would like to. So this has led us to ask ourselves, how can we go faster? So how can we rapidly scale the adoption of Unity for all our data? And so let's look at how we've been approaching this problem. The first step we've taken is to essentially stop the growth of our Hive metastore. So as a starting point, we've updated our production standards to mandate the use of Unity Catalog for all new data, but there's really no guarantee that people will follow the standard. So we decided to enforce it by blocking write access to Hive for new tables. So first we started by providing a catalog in Unity for people to be able to create ad hoc and test data in a development workspace. So it's really easy to access. And then we started blocking access to Hive for creating databases and also tables. This worked well for us, but we did end up breaking things in the process. So just, I guess, word of warning. It turns out that some of our existing jobs were configured to essentially drop and recreate tables every time they run. And that's using a specific operation mode in Spark. So we weren't aware of this, and we ended up breaking pipelines. And, anyway, we've moved on from there. We fixed the permission, and now we're in a much better place. So I guess stopping the growth of Hive is a massive step forward, but it really only applies to new data. So what about our existing data? So we have tens of thousands of tables. We have thousands of databases in Hive. So it begs the question, is migrating all these tables realistic? Do we actually need all of them? Or can we reduce the scope and clean things up in the process? So to find out some answers to these questions, we've leveraged the Databricks system tables, specifically the HMS to UC migration schema, to identify which tables and S3 locations have been accessed recently. So that's allowed us to reduce the scope of our migration from tens of thousands of tables to around 1,500 active tables. So that's a much more manageable number. It's about 5% of our total number of tables in Hive. Also, additionally, we kind of established that the goal of the migration is not about adhering to medallion principles. It's really just about enabling the benefits of Unity Catalog as quickly as possible. But we face some challenges doing that. So our first challenge is that the physical storage of our data is pretty decentralized. So our data is stored in multiple buckets. They're owned by different teams. They have different permission models over different IAM roles. So it's not really a simple lift and shift. The second challenge that we faced is that some of our data is not written in Delta format. So we're still unsure about how data partitioning will work in Unity compared to Hive. Another one of our big challenges is that we run many clusters, many jobs, and a lot of those use older Databricks runtime versions that are incompatible with Unity catalog. So we must ensure that everyone gets their versions updated. And finally, we want the migration to be code-free. So that's something that we must keep in mind. So what's our plan for approaching this? So essentially, our strategy has been to first launch a campaign to upgrade Databricks runtime versions across our whole organization. And I guess we expect this to take some time. Next, we created a playbook for how to migrate individual tables. So the first step is basically to ensure that the IAM role that we use in Unity Catalog has all the required permission to read and to write data where the table that we're migrating is stored. Then we create an external location in Unity to point to that location, and then finally an external table that will basically point to that location. So all those tables that we're migrating are stored in a dedicated catalog that we've created alongside our medallion catalogs. And when migrating those, we also ensure to keep the Hive database names, map those directly to schemas so that we can basically have like code-free migration. Finally, the last step here is to ensure that we set up permissions in Unity so that basically the owners, the consumers of the data can access the data via Unity just as they used to in Hive, but using service principals or user identities instead. So once we'll have done this for all the tables in scope, we'll basically be in a position where we can change the default catalog that all our jobs, our clusters are using, so that essentially we're now pointing to that new catalog we've created. So we should essentially be replacing Hive Metastore like for like from a consumer point of view. So making progress is really important to us. So we've basically reused and customized a dashboard provided by Databricks to measure essentially how we're doing on our migration. So here we are tracking the percentage of external tables we've created so far, how many we've got left, and we can see the progress of that on a day-to-day basis. And as I mentioned earlier, one of our biggest challenge remains the upgrade to versions of Databricks, the Databricks runtime that is compatible with Unity catalogs. So we've also created a dashboard to track that and to share with owners of the jobs, the clusters that rely on those older versions. This isn't a simple update, and given we have hundreds of developers, data specialists operating hundreds of clusters, it does take time. It's also that we're competing against other priorities in our organization, so not everything's about data governance. But fortunately, we anticipated that and we started early. We're getting pretty close to the finish line. So that's pretty much it for the deeper dive. Hopefully this was useful and it shows you an example of how we've enabled Unity Catalog to accelerate our migration and also to improve our data governance. So back to you, Michael.
Right, thank you very much, JM. So we're going to wrap up with a couple of kind of summary points on where we are today and some kind of what we kind of view as kind of important takeaways from this. So back to our staircase, we're continuing to scale adoption. I think that chart is probably from a couple of months ago, but we're expecting to have pretty much everything in Unity Catalog in the next kind of couple of months. So that's going to be a great breakthrough for us. But I think I've said a few times today that we're operating at scale, and when you're operating at scale, we're actually changing the way of working for like hundreds of people, and that's one of the biggest challenges, and these changes do take time. In parallel to all of this, though, so this is not a strict linear sequence. In parallel to this, we are now actually using some of our governed data, where we have a kind of readout on the health of the data and the trust in the data, to power some of our data and AI-enabled use cases. So we've got this concept of the data and AI flywheel, where we have apps, websites that are generating large volumes of events. It's like 30, 35 billion events per day. And then this data is landing inside our architecture. We're transforming that data. We're using it to enrich like the models, train models that we're working with, and we use it also to power different use cases. So this data is then shared back to the operational side, the operational realm, and then from there it powers features within the app, and then the circle continues. So one of our concepts here is we want to accelerate this data and flywheel so that we can build better products faster. So what have we found useful? I think data maturity assessment was a great help to help us understand what good looks like. It gave us an action plan coming out of that assessment, and it allowed us to hit the ground running. And a shout out to Lexi from Databricks, who helped us on that specific journey. So not all data equal has been a kind of recurring theme throughout our experiences. And this allowed us to really give focus to what data sets are important. And we're going to start there first so that we maximize business impact. But then system tables kind of kicked in and helped us also to focus in a slightly different way, because that allowed us to focus on the active tables instead of like worrying about migrating every data set that had been built up over the years. And that helps us with our long tail of data. Medallion was a great starting point for us. It allowed us to get started. Getting all the data landing in bronze has been good. But we've since, Jay mentioned this, we've prioritized the benefits of Unity Catalog, and actually getting that visibility of lineage and the visibility on the trust in the data will actually make it easier for people to migrate to Medallion in the future. And of course, Monte Carlo gives us that kind of observability in the data as well. And so we're prioritizing Unity Catalog and Monte Carlo over strict Medallion architecture. So operating at scale is really important to be able to make progress, show where we are, measure progress, make it visible. And this is really important for keeping up momentum. And like these changes take time, and it's important that people who say, actually, it is getting better. We can see how things have improved over a longer period of time. And lastly, we're collaborating with hundreds of engineers. Not all of these engineers are data specialists in our case. We've got many application developers and such like. And so we need to be really clear on the priorities and the asks that we go out so that they know why it's important and here's what specifically we need you to do. And so that's our journey. Thank you for listening. Hopefully some of that resonates with yourself. I've got about a minute left, so I'm going to say a quick couple of thank yous. So the Skyscanner teams that built this, myself and JM, we've been part of that journey, but we've got a lot of people who have kind of contributed to this. So they were boosting reliability, enabling trust in their data, enabling faster, smarter decisions using data. One of our colleagues in particular couldn't travel to be here, Katrin Korofkina. She helped us prepare this talk. And we also want to give shout out to the Databricks teams and Monte Carlo teams who have been really, really supportive of us in this transformative journey. If you do want to know more, there is a blog on databricks.com, their blog area, that tells a bit more of the story and a few different points as well. Thank you very much.